This is fascinating. We have just gone from one-dimensional sweep circumference to a two-dimensional area. Agreed? Yeah. Now, what do you think our next logical step is?
Three dimensions.
Done. So now we're going to do volumes. And we are going to find volumes for both cylindrical coordinates and spherical coordinates. And trust me, it's going to be simple. Because once we understand this, all it is adding another dimension to it. That's all. That's basically all it is. Ready? So we now have a three-dimensional coordinate system. In this three-dimensional coordinate system, let's just do cylindrical first because that's the picture I have. So this coordinate system, I want you to place your coordinate systems in front of you. The way this is pointing, X should be pointing towards you, Y should be pointing, and X should be pointing. And I want you to tell me where 2, 3, 1 will be. Somewhere in? Good. Somewhere in space is where it lies, right? Okay. Now, on this coordinate system, I want you to imagine that you have a cylinder. I want you to place this imaginary cylinder on your coordinate system. And I want you to think about what it would be, what it would require for you to do. Well, one of the things that it will require you to do is draw a projection. So I'm now on figure 2. Down onto the XY plane. This radius at the bottom is the same as that radius at the top. You see that? And now we're going to start talking about sweeping it. So we have our circle base as always at the bottom and at the top. And we are moving our arc around. But instead of forming a circle, this arc will form a cylinder. Does that make sense? Right? So it's just sweeping the same area, but it has an extension up now. So it's going to form a cylinder around. Got it? So there are two types we can do. We can do a empty one, and then we can do a filled one, right? So if it's an empty one, does anyone remember what it's called? It's called a surface area. Does anyone ever remember what the formula is? And the answer is no, because it's kind of complicated. But do you guys want to know the simple way of doing it? If you use calculus, it's very simple. Okay. So when we talk about, so imagine, this is what you're imagining in your heads, right? So there will be a sweeping thing, right? So I'm going to try to draw it. And this will go around, right? And we're going to go all the way around. So now we have to find this dA. So we are actually going to have a combination of two things. Two circles plus surface formed, I'm trying to come up with words for it, surface formed due to height. So there are two circles. Yes, there's a top circle, there's a bottom circle, and there's also this surface that needs to be taken into account. Are we clear? Okay, so my two circles will give me, I'm going to call it dA, the same way we did for regular circles. It will just be A equals R dr d phi for the area. And I will just integrate. And what do I get? 2 pi r squared. Okay, now what about the surface that was formed due to height? So I'll call this 1 and I'll call this 2. What will that be? Well, it still has the sweep, right? But instead of having the dr, what does it have? Yes.
I'm confused. Last time we did R dr times integral of d pi. We canceled out the 2's.
Right.
R.
That is true, because this is now due to two circles.
No, we just
Right,
did
you
the
just
first
did the
circle.
first. So
Okay, so we did the first circle?
Yeah.
And now convert it for two circles.
Okay, I think that was, we didn't know. What to do, right?
So A1 is the first circle, then A2 is going to be that.
Right, so remember we said two circles?
I thought you were just
We
breaking
got
it
it.
out.
Oh, okay, here's what I could do. If I do this, will that make it better? Will that make it better? Okay, good. Thank you for pointing that out. Oh, we're all happy, right? Okay. Now, in this case, so now for the second case, it'll be dA2 equals R d phi dz. It's still sweeping, but it's not moving outwards. It's only moving upwards. So what will be the limits of integration in this case? Well, we are going to have R is common out, constant, nothing will change. It'll be d phi and dz. dz will be limit 0 to h. d phi is always limit. And we will have r 2 pi h. But because this is now a surface area, what do I have to do in order to find the total surface area? A1 plus A2, which is 2 pi r squared plus 2 pi r h. And in most textbooks, you will find this written as surface area equals 2 pi r plus h. And for the life of me, I can never remember this formula. So in my head, I always think two circles and a sweep, right? So as long as you can remember that, you remember pi r squared, two circles is 2 pi r squared. And then all we have to do is remember that we're still sweeping, but with a height. So this is what you should remember. Two circles, a bunch of circles joined together. That's it. It's not any more complicated than that.